Good afternoon, and thank you for joining today's webinar from SPEC Innovations. Santa is a systems engineer. My name is Taylor Duffy, and I'll be the moderator for today's webinar. First, I'd like to go over some housekeeping. Next slide. During the presentation, feel free to send us questions, and we will get them answered in the Q&A part of the webinar. You can also interact with us on LinkedIn through the Innoslate users group or through Twitter using the handle @SPEC Innovations. The webinar is being recorded and will be made available to you after the live presentation, so keep an eye out for it in your inbox. Now, I'd like to introduce to you our presenters, SPEC interns Dominic Galarza and Amir Abrari. The SPEC stars are systems engineering interns currently working on their Masters of Systems Engineering at George Mason University. Feel free to send them any questions through the LinkedIn users group or an email to dominic.galarza@specinnovations.com or amir.abrari@specinnovations.com. And now I'll hand over the controls to them and we'll get started.
Hello everyone, I'm Dominic, and so to begin, I'd like to go over the agenda for today. Our goal is to show how Santa was able to use Innoslate during Christmas as a systems engineer. And so these are some of the things on our agenda. We're going to be starting off with the project timeline diagram, going through the documentation, the various sleigh variants, going through the reindeer, radar diagrams, going through the naughty and nice list, and then ending off with the simulation and risk evaluation. This is Santa's timeline diagram that allows him to keep track of deadlines and his Christmas schedule as he prepares for this year's Christmas. Santa's Christmas timeline includes deadlines such as creating gift lists, naughty and nice lists, Christmas Day route planning, and all the above, which have been analyzed throughout this project using Innoslate. This diagram also includes milestones throughout the project that must be completed by the assigned deadline. This feature attributes task descriptions, beginning end dates, due dates, task durations, current status, assignees, and percentage task completions. Additionally, Santa was able to customize the timeline length and overall duration based on his needs. In this example, the timeline length is for a year, but if needed, it can be adjusted as long as the user needs using the Adjust Timescale button to account for long-term goals and milestones. Requirements documentation is an essential part of systems engineering. Using the requirements document on Innoslate, Santa and his team created detailed requirements on mission, operational, functional, and performance aspects of the project. Each requirement follows the INCOSE guidelines for requirements engineering. This feature includes the entity, the requirement, its rationale, quality score, and appropriate labeling and requirement status. Each requirement or each element is essential in documenting the requirements to be later traced and verified in the project. Santa was also able to use the quality score feature to get quantitative scores for the requirements he and his team made. The quality checker takes into a factor clear, complete, consistent, correct, feasible, traceable, and verifiable requirements, components, and scores each requirement accordingly. The document view enables entities to display letters such as V or T to indicate relationships with other entities. For example, the very first entity shown there has a V verified to TC.1. So over here, I'm just going to go through the iterations of Santa sleighs throughout the years. So the first iteration of the sleigh is relatively basic. The model shown is most likely the very first thing you'd think of when it comes to Santa's sleigh, being rounded on the edges, 2 bars on the bottom, and with flourishes on the ends. There's also a bench-style seat with space for Santa's gift sack behind it. The CAD viewer in Innoslate's database allows Santa to store this information and view it whenever needed. Going to V2 of this iteration, the second iteration of this sleigh improves upon the technical aspect of the previous iterations of Santa's sleigh by adding one big feature, lighting. As you can see in the model, the new sleigh design now has headlights towards the front, further improving upon the initial version of the sleigh. So over here, V3, the third iteration of Santa's sleigh model adds a futuristic flavor to the previous designs. In addition to those stylistic changes, another big addition is the rocket engines that can be seen towards the back, next to the gift compartment. Over here, for Santa's V4 design, the futuristic components of the third iteration were adjusted into a more industrial and practically speaking first type of design. In addition to the rockets from V3, V4 also adds fans to increase lift. And finally, for V5, the final iteration of his design, it incorporates the best parts from the previous models, the looks from V1, the lights from V2, the rockets from V3, and even the fans from V4, and all of which are stored in Innoslate's project database. Over here, this is a spider diagram of Santa's Slate components, highlighting relationships between each of the different parts and components of the physical architecture. The relationships between the assets in the spider diagram are rooted in the hierarchy diagram, which has Santa's sleigh as the root, with each of the arrows pointing outward being branches of the root. Then, once the diagram is decomposed, we were given the relationship between the assets. This figure allows for appropriate relationship tracing and ensuring that our system components are related to each other at all times. Much like the Slate component slide, this slide lists the hierarchy of North Pole HQ rather than the sleigh itself. This diagram is called HQ.1, Santa's throne, and can be found as either a spider diagram or a hierarchy diagram in the diagrams menu of the project.
Hello, everyone. This is Amir speaking. And as we all know, on Christmas Day, Santa will be riding his sleigh with the help of the mysterious reindeers that he chooses. As a result of that, we decided to create a ranking system using the radar charts to rank these reindeers in order of importance and priority based on system needs and as well as Santa's preference in which ones. We will be using this demonstration to show Innoslate's ability to communicate attributes and comparative advantages of certain components against one another. It is important to note why this demonstration is being done and how it will help Santa. The radar ranking system will help Santa in sort of like a pie chart, make the difficult decision of choosing which reindeers are fit to help him based on the attributes that define them, as well as the weather conditions and the travel that he has to make. Which is why here we can see Rudolph's attributes and rankings as it stands. The radar chart consists of 5 main factors that I mentioned before: cold resistance, heat resistance, speed, stamina, and strength. Each of these attributes were ranked from 1 to 10 and created the radar charts as a cumulative chart that combined these numbers together. These ranks are shown as the circles over here and then go throughout from 1 to 10. These rankings together create the diagram that's shown in blue. Next, in the database view, Santa was able to use the saved queries feature to create different queries lists and decide on various elements of the project as he decides to take on Christmas. Each list has a unique number of elements that create the query, different labeling, different sorting options, and configurations that we have for our database create the queries that we have. Then we can go ahead and save those queries for a project and to our project for all users to see. The feature can also activate multiple labels at once, leading to the system identifying common denominator within the query list that can apply to both. For example, you can click the label apparel and the continent of Africa, hence making the list smaller because it identifies the common labels. It would have to be an apparel that's in Africa. So these combinations can help us again find the common denominators, and that's something that we see in our database view that can give us very good potential and extensive and dynamic lists that we can create in that way. Again, labels can be created in the schema editor, so it is important to note that they can be added or removed upon the discretion of the project owners. As a result of that, Innoslate has the capability to customize the project in endless ways so that Santa can deliver the best Christmas. Additionally, it's important to note that Santa and his staff created different labels to assess these children's and whether it's their gift and the location of their request. So these 2 labels were categorized in 2 ways. It's apparel, electronics, and toys, as well as their continent. So we have our gift categories and our continent list. We can see an example here in this slide. We have the nice list. This is our query for the nice list. The nice list query in this slide focuses on kits from all regions that have been good. The query includes entity properties such as gift list, country, region, available at Santa's disposal. The query list is created to save progress in order of operation for standardized process for Santa. Santa has to look at these lists to see what continent they have to go to, what kid was nice, what kid was bad, which will we see in the next slide. In this example, again, Santa needs a query list of kids that have been nice, the gift they have asked for, and the country they are in. For example, in red, we see Alfred Simmons. He is a part of the nice kids list. He has asked for an Alexa, a t-shirt, and a puppet. And he also lives in Australia. As a result of that, we can see its labels. He's asked for an apparel, which is a t-shirt. He's in a continent, Oceania, which is Australia. He's asked for an electronics, which is an Alexa, and he's asked for a toy, which is a puppet. So we see those labelings allocated to one another based on the attributes in our entity. For another example, we have the naughty list over here, which focuses on kids from all regions that have been naughty. Similar to the nice list, the feature addresses all the necessary information to Santa in one particular view and database view. Again, to demonstrate an example, highlighted in red over here, we have Michael Harris. He is part of the naughty list, and he has asked for a PS5. He lives in the United States. As a result of that, his labels mention continent, North America, because of the United States, and label of electronics because of the PS5. These labels are important to us because we are able to use these labels later on, again, find those common denominators, and find different lists of different attributes and different entities come together.
Thank you, Amir. So shown here is an asset diagram which displays Santa's travel path during the night of Christmas. The background of the asset diagram has also been changed to a time zone map, which matches the action diagram found in the slides, where it includes the simulation, which is later in the webinar. So in this example, Santa and his team has planned out the routing scenario for Santa that best optimizes his travels around the world. Such illustration is a great method of communicating the travel plan, as well as using the asset diagram to then simulate the plan and estimate results. A test center has also been created to allow for verification and validation of our requirements and processes. The test center includes the entity, expected results, actual results, status, progress rollup, and appropriate labels. These components can be deemed extremely helpful in utilizing a test management tool that will accelerate system and project testing in any environment. It's important to note that these structural attributes can be always adjusted and catered towards the stakeholder needs. You can always add or remove certain attributes. Additionally, test center entities, like any other, can be related and linked using the relationship tab on the left to create traceability to requirements and create a direct verification and verification for our requirements. So that kind of goes back into the V and T I've seen earlier in the requirements document. Task lists are an essential part of project management. The Kanban board creates an interface for project managers to lead projects and divvy up tasks between different assignees. This allows for an appropriate task management and a process of communication between project leads and assignees. This feature enables the project manager to create a description of the task, assign users to the entity, set due dates, estimated time dates, finish dates, completion percentages, and move entities between the stages upon completion of an activity. The Kanban board can be converted into any SysML or LML graphical representation available on Innoslate using the Open tab. The Gantt chart is also a notable feature that can work hand in hand with the Kanban board in the project management section.
Thank you, Dominic. So as we have Santa be a system engineer, he also has to do some risk evaluation. In this example, Santa does some risk evaluation in order to fully prepare for what's to come. In order to do so, Santa has to list all possible risks he could face and evaluate each risk based on its consequence and probability of happening. The consequence and probability percentages indicate the location of each risk on the table. Depending on the numerical percentages of each element and entity, the risk will be positioned in a specific column/row based on the importance of the risk. It is crucial for the team to conduct risk analysis in order to ensure the safety and success of Santa's work and hence mitigate that effort. Each risk has attributes that will allow each user to conduct the proper analysis. These attributes include description, consequence description, consequence and probability percentages, And finally, the current status of the risk, whether it's open, duplicated, declined, or resolved. We see plenty of risks over here. From the very top left, negligible and high, we have no chimney on the delivery home. For another example, a risk on the top right that will be very critical towards the failure of our project will be that child does not fall asleep before delivery. Obviously, that's very critical because that would ruin Christmas for the kids. So we want to make sure that that's listed and that's mitigated in different ways. In this slide, we see the overall timeline simulation analysis. The action diagrams were created to map the start to end progression of tasks based on time, duration, start and end dates. Now, these tasks were created based on a timeline diagram, which, as Dom mentioned before, you can use the open feature for the open tab, and then we can get different SysML and LML diagrams out of that. Again, they were directly exported from the timeline diagram, allowing for simultaneous updating and progression towards project goals. Both diagrams will change as one changes. So it's very important to note that this is simultaneously changing and evolving over time. And we do discrete event simulation to get the post results. These simulation results for the overall timeline of Christmas preparations are a discrete event simulation, which follows the events of the timeline diagram as seen earlier, and then the action diagram that was generated from it. Additionally, the simulator also shows a Gantt chart in the bottom that can portray our results. As we can see here, we have our action trace in a 3D method that can be toggled and viewed at different angles. We see our total time generated from our duration attributes from each entity that is in the action diagram. So our action diagram was able to be generated, was able to be simulated, all with a bunch of clicks that are totally automated. Then we were able to extend the action diagram model from the previous step that I just showed you through incurring cost to some of the elements. We created cost relationships per hour for building toys entity. We thought to ourselves, at what stage does Santa have to incur cost to its project, which was when we had to go ahead and create these gifts, as the elves will be helping Santa as part of his team to create these costs. As a result, we were able to incur cost to these elements and entities. Doing the simulation allowed Santa to create a precise estimate of what to expect on how much to budget on the project to make sure he remains feasible. We can see here the total cost of the project, the total time of the project, the tree map in terms of what entities took the most amount of cost and time. Again, our Gantt chart that's been consistent from the previous slide. We see our cost over time. We see in April, costs start to ramp up, and from April to August, we have the biggest spike, which is where elves are going to be creating our products and our entities and our gifts, really. And here we see our pie chart and a cost breakdown of our work. For Christmas Day timeline simulation, we have this slide over here. The Christmas Day action diagrams shows the amount of time it takes for Santa to deliver the gifts across the world. The action nodes can be decomposed into second and third level action nodes, all of which will be accounted for in the simulation. The goal of the simulation then is to calculate the total time it takes for Santa to depart from the North Pole, travel through all of the different time zones, and then head back to the North Pole, all of which should be under 24 hours. We wanted to check that, again, verify and validate that. When Santa departs from the North Pole, he will have about 4 hours in each time zone to deliver gifts to all the kids within that time zone. When one night ends in a specific time zone, the other begins. This allows for our discrete event simulator to run throughout the model and throughout each of these nodes to make sure that you are staying consistent under the 24-hour mark. And here we can see the results. We can see that within each time zone of 3 hours, we stayed in and we got out of it. The simulation of the results, we can see a 3D rendering of the diagram, a Gantt chart from the diagram as mentioned, and we can also confirm that upon that, we stay under the 1 day mark. That's a summarization of all the efforts and works that we've put into the project, and to do Christmas as an engineer, as if we were Santa. So now it's time for the Q&A portion of our webinar.
Thanks, guys. If you haven't already done so, feel free to ask your questions through the panel on the right, and we'll get those answered for you. So the first question is Santa a systems engineer or is he an experienced executive that knows how to employ the team, including systems engineers, to manage the program?
We believe definitely the second option as an executive, because even when we set up the problem with costs and with time, we incurred different, we made sure that Santa has a staff, whether it's elves that are getting paid for their time, whether it's making sure that all those components are taken care of. We try to combine both, have him be a system engineer, but also manage this project using Innoslate to best do system engineering and project management at the same time.
Next question. How much time did Santa and his team have to spend to develop his project in Innoslate?
So the course of the project going on for about a year. We didn't really mention any time before in the previous years, but we allocated the project to be just 12 months, just from January, or rather the end of Christmas to the start of next Christmas.
How much time is estimated to be saved by using an integrated database systems engineering tool, namely Innoslate, ensuring on-time product delivery?
So I think that for one, it being a cloud native service, it can be reached at any time. That definitely saves a lot of time in those sakes. And in others, whether it's risk mitigation, whether it's scheduling, whether it's making sure there's less delays within your project and mitigating it, the verifications that we did, the timeline checkings, the simulations of those timelines, all were a part of contribution to making sure that, for one, you stay on schedule, you have good performance, and also make sure that the cost, so cost, schedule, time, performance, and time, all those facets are things that we think of, you take care of, and we try to show in this demonstration that even in the context of Santa taking care of Christmas can be done.
I also say, to add on to that, we may not have hard numbers for the sake of this presentation, but it's something that we would able to research and then get back to you offline with that question.
That sounds great. Going back to the last question, the question on time was about how much time it took to develop this project.
Oh, so we developed this project a bit ago. I think maybe a week or two. In terms of our effort, it was Dominic. We worked on this obviously with Chris. When Chris came in, our time and efforts came maybe 2-3 weeks max, and we were done with this project. So, but there's a lot of effort, there's a lot of work. This was just a surface level of like how much we could have shown a lot of the amount of time.
Great. Will a risk burn down chart be part of the risk diagram for certain risks?
Yes. So that was another consideration, was a risk burn down chart of how over time, because our risk burn down chart has the risk itself and then the time. An extension off of that would be to definitely show how the risk is mitigated on the burn down with time, and we can relate issues, and we can relate things that will mitigate. So mitigates will be a relationship that we could use to show that and incur that change on the risk burn down.
Great. How were you able to incur costs into entities for the simulation?
Yes, so that's a great question. The way we were able to incur that cost was there's a relationship cost with pretty much action, especially action entities. There's a relationship that we can make with incurs cost, and that cost allows us to either do obviously numerical values, but we can do per hour or a fixed rate. And once you make that relationship, that will automatically identify it to the entity and be able to show it in your simulation. So if you have that cost incurred, it will be able to identify that in the discrete event simulator and generate that. If it's fixed cost, then it'll just apply that cost once. If it's per hour, then over the amount of time that you run the simulation for that entity, it will incur that cost and it will account for it in your simulator.
Wonderful. And this looks like our last question. Why did Santa choose the combination of routes he took in the asset diagram?
Yeah, so going from the asset diagram, you were able to see the entire map of the world there. And so doing a whole Christmas operation in about 6 to 12 hours, which is the course of a nighttime would be relatively impossible even for Santa. And so in order to do that, I took the Earth rotating. So the Earth rotates on from the left to right. So that means sunlight goes from right to the left. And so Santa would start his journey on the right side of the world, so the Europe, Asia side, and then he'd continue going to the left. On the asset diagram, I didn't mention it during the webinar, but he has green stops and red stops. Most of the stops on his travels are green, which means he just delivers the presents, no problem, and moves on to the next one. The red one is where he would stop and take a little rest. We have allocated time in our simulation in which he would go take a little rest, he would feed the reindeer, he would assess any damages, stuff like that.
Yep, we can show here the green is where he skipped the gift, and the red is where we allocated rest. So we allocated this rest, and those rests were also calculated.
Yep. And he would continue that all the way through, going through each of the areas of the world and then going back into the North Pole to end the night. Up here.
Great. Thank you both. If you could go to slide 29, I'll go ahead and close this out. We would like to thank you again for joining us today. As a reminder, we'll be following up with you very soon to send you a link to the recording and the presentation slide deck. We hope you can join us for our next webinar with Dr. Stephen Dam, Cybersecurity Engineering using Innoslate, on Tuesday, January 23rd at 2 p.m. Eastern. Be sure to register whether you can make it or not to receive the slides and recording. We also encourage you to visit our website and our blog, as well as connect with us on social media. That concludes today's presentation. Have a wonderful day. We hope to see you at our next webinar. Merry Christmas.
Thank you, everyone.
Merry Christmas.